The notes today are going to involve circles. So we're going to go through and talk about some different aspects of a circle. First, how many degrees are in a circle? So basically, if you start here and go all the way around, how many degrees does that make? And the answer is 360. We will need that information for some of the problems we're going to work on in just a little bit. The circumference is the distance around the outside of the circle. So the distance around the outside of a circle. And the formula for finding it is C equals 2 pi r. And we will need that later as well. Suppose the circle to the left has radius 1. So if this would be the radius, remember the radius goes from the center of a circle to one of the endpoints of a circle, but does not go all the way across. That would be the diameter. If this circle, the circumference of this circle, if it has a radius 1, you just plug in r equals 1. So circumference would be 2 pi times 1, or 2 pi. And we're just going to leave it in that form for right now. A circle that has a radius 1 is called a unit circle. A unit circle is very, very important, especially in trig and in calculus. So very important for trig and pre-calc as well as calculus. The arc length of a circle, so let's look at what that would look like. So an arc length is basically going around some portion of the outside of the circle. So the arc should have a curve to it. So if I were to extend and make this an angle, so let's just say there, this is your angle measure. Well, this piece on the outside is your arc length. Okay. So the arc length is basically some portion around a circle. So the distance of some portion of a circle. And it does have a formula that we will be using today. So in order to find the arc length, you're going to take the arc measure, we'll call it measure of arc AB, and it's curved on top representing the arc, divided by 360, because that's the total degrees of a circle, times 2 pi r. And this will be what we use for most of the notes for today and for your homework for tonight. So this formula is really, really, really important. So the arc length divided by 360 times 2 pi r. So let's go ahead and look at some of these first examples. So the first examples say you have a circumference of 2 pi. If the arc length is a unit circle, so that's code right there. When it tells you it's a unit circle, that's telling you that your r's for all of these will be 1. That won't be the case with all of them, but it is for these first few that we're going to do. It says show where they would be on a circle. So just to step back a second and just go over what a circle is made of. So if I took, I know that's a horrible circle, and I broke it into 4 pieces, each piece is equal to 90 degrees. So like from here to here, that's 90 degrees. From here to here is 90 degrees. From here to here is 90 degrees. And from here to here is 90 degrees. So when they ask you to find 180, you would do a 90 and then another 90. And so it would basically be half the circle. So for the first problem, let's mark it on our graph what it looks like. So 180 degrees, so just to familiarize ourselves, would be 2 pieces. So it would be basically extending this radius to make it a diameter. So 180 degrees is here. And we want to find the arc length, and the arc length is this curved piece here. So we'll use our formula. Please don't forget they gave us the r value. This piece right here was our r, and they told us it's a unit circle, so we know that has a value of 1. So our formula is the measure of the arc, so 180 over 360 times 2 pi, and our r is going to be 1 for all of these, so you can write it in. I'm going to drop it in a little while just because it's not needed. So all 4 of these will have the same r value, and then you'll just work that out. So this will give you 1/2 when you compute that times 2 pi. Your 2's will cancel, and you're left with pi. So the arc length of 180 degrees is equal to pi. Then we'll do that for the rest of these. If you want to pause the video and try some of these, you're welcome to, and you can come back and see if you got the answers right. So 90 degrees is just 1/4 of a circle. So 90 degrees, again, here's my r. My r is 1. I want to find this arc length. So I'm going to do the math down here for that one. So it's the 90 degrees divided by 360 times 2 pi r, but all of our r's are 1, so I'm just going to eliminate it since they all have the same r value. 90 over 360 is going to be 1 over 4 times 2 pi. These will cancel. If you put them 1, that's a 2. So I get pi over 2. So the arc length for 90 degrees is pi over 2. 60 degrees now is not exactly one of our pieces, so you're just going to estimate it. So if you know that all the way to here is 90, so maybe just go this piece of it, and that would be 60. It's just an approximation. It does not need to be exact. So I'll say it's about there, 60 degrees. And the arc length that I'm finding is this piece here. I have the same r value again, so my r is just equal to 1. So when I do the math, so 60 over 360 times 2 pi. Again, we're not going to put r in since r is just 1. This reduces to 1/6 times 2 pi. Cross cancel. So you should be getting pi over 3. And then our last one is a 45 degrees. 45 degrees is exactly half of 90. So probably about, trying to visualize it, probably about there. So 45 degrees, here's my r. So the arc length I want to find is here. So then I'm going to do that work down here, just so you can find it. So here we're going to do 45 over 360 times 2 pi r, but again, r is just 1. This reduces to 1 over 8 times 2 pi. Put it over 1, cross cancel, 1, 4. So I get pi over 4.